Math 1314, Tyler Junior College, Section 1.7, Linear and Absolute Value Inequalities. Absolute value inequalities, greater than. You can infer from the title that the next video will be about absolute value inequalities, less than. Let's tackle greater than first. For example, solve the absolute value of 3x minus 1 is less than 20. Just a little side note, whenever I have a problem with both absolute values and ones, like this one, in order to distinguish between them, I will sometimes make my one a little bit fancier with a little hat and a little platform to stand on. So it looks different than the absolute value bars. So how are we going to solve this? What's your first instinct? Is your first instinct to add 1 to both sides? It looks tempting, but I would resist that temptation for a really simple reason. The minus 1 is currently inside the absolute value. If I write a plus 1 out of nowhere, it will be outside the absolute value. Things inside the absolute value can't be added to things outside the absolute value. So I'm going to refrain from adding 1. At some point I should add 1, just not yet. So how do we attack this? Well, the secret to attacking this is remembering what absolute value means. So just as a reminder, absolute value measures the distance from 0. The distance from 0 on a number line. This was discussed in a previous video in the previous series, but for example, if I asked you the absolute value of 4, what I'm asking you is how many spaces are between 0 and 4, and the answer is 4. But if I ask you the absolute value of -5, the absolute value of -5 is the number of spaces between -5 and 0, which is 5. Numerically, it turns negative numbers positive and leaves positive numbers alone, and leaves 0 alone as well. So it turns negative numbers positive and leaves non-negative numbers alone. So how can we capitalize on that? What does that mean in this context? Well, if we think of this in terms of distance, what this is saying is the distance from 3x minus 1 to 0 is greater than 20. Okay, I think I could draw a picture of this. Let's draw a number line. Let's put 0 in the middle. And because we're talking about being 20 spaces away from 0, let's go 20 to the right and put 20. But let's also go 20 to the left. Because when I say my distance from 0 is greater than 20, I'm not saying which direction I'm going. So, where on this number line could the 3x minus 1 be if its distance from 0 is greater than 20? Well, if it was more than 20 spaces to the left of 0, it would be over here. That is more than 20 spaces away from 0. But if it went to the right of 0, then 3x minus 1 could be over here. More than 20 spaces from 0. Okay, so visually I know where the 3x minus 1 could be located on the number line if its absolute value was greater than 20. But how does this help us solve? Well, what's the relationship between 3x minus 1 and -20 in terms of greater than and less than? Since the 3x minus 1 is to the left of -20, that means that we need 3x minus 1 to be less than -20. Or the 3x plus 1 relative to the 20, which of these is greater? The 3x minus 1. I know that because visually it's to the right of 20. So putting the 3x minus 1 over here says that 3x minus 1 could also be greater than 20. So the 3x minus 1 can satisfy one of two conditions. Either it's less than -20, so more than 20 spaces to the left, or greater than +20, more than 20 spaces to the right. At this point, it is no longer an absolute value inequality. It is a compound inequality. See what I did there? So to finish solving this compound inequality, an OR inequality to be specific, we solve each one individually and take the union of their solutions. So let's solve each one. Add 1 to both sides here, and we get 3x is less than negative 19. Divide both sides by 3, and we get x is less than negative 19 thirds. An inconvenient number, but it's correct. Or, this one will be a little nicer. If we add 1 to both sides, we get 3x is greater than 21, and then if we divide both sides by 3, we get x is greater than 7. So we know how to finish this. To find the solution to an OR compound inequality, we find each interval and take their union. Because we're looking at negative 19 thirds and 7, we need to put both of them on a number line with the lesser number to the left and the greater number to the right. The numbers less than negative 19 thirds are to the left of it, and because it says less than, but it doesn't say or equal to, we don't want the negative 19 thirds, which means we put a parentheses on it. And for x is greater than 7, those are the numbers to the right of 7. And again, we don't include the 7, so parentheses opening towards the right. So if we join them together as a single answer, the left interval is negative infinity, comma negative 19 thirds, parentheses, union, parentheses, 7 comma infinity. That wasn't too bad once we figured out what the absolute value meant and how to capitalize on it. Again, absolute value means distance from 0, so we need this to be more than 20 spaces from 0. More than 20 to the left, more than 20 to the right. But can we generalize this? In other words, can we figure out a way to get from the beginning, which was here, to the point where we actually started solving, which was here? Let's think about what actually transpired with the pieces here to get us here. We set up two inequalities. We took the original contents of the absolute value and put it greater than the number that we had. Almost as if we just took off the absolute value and said 3x minus 1 is greater than 20. But we also took this number and put it less than the opposite of that. So I think we can say the following. Okay, I know we can say the following. To solve absolute value of something on the inside is less than a number, comma, set up and solve the following. One of our inequalities was the inside greater than the original number. Inside greater than the original number. In other words, excuse me, this is incorrect. To solve absolute value of the inside greater than a number, that's what we did. So the first one you set up is the inequality without its absolute values. So you just imagine that you get rid of them and you solve that. And then the word or, and remember, the word or here doesn't mean you get to solve one or the other. You solve both, and the word or means you take the union of their intersections. The other inequality we solved was the inside less than the negative of the number. Inside less than the negative of the number. So there's our strategy for solving an absolute value greater than problem. I'd like to do one more example. Let's see where we are time-wise. A little under 10 minutes. I think I can fit in one more example pretty quickly. Now that we have a plan of attack. Some of you are probably asking yourself, why didn't I start with this? Because I'm not just teaching you how to do math. That's like teaching you how to put gas in a car. We can all do it, but do you really understand how that works when you pump gas into a car? I'm trying to get you to problem solve. In other words, when you run across a new type of problem, how can you take the knowledge that you already have and apply it to solve a new situation? And once you come up with a plan of attack, you can use it in the future. So let's try this one. Solve absolute value of, why not, x minus 1 over 3. Oh no, a fraction is greater than or equal to, we'll say 4. Now we could draw the number line again. You could even think it or talk it out. You have to be more than 4 spaces from 0. So to the right of 4 or to the left of negative 4. Or you could just set this up, which is saying the same thing. If you have absolute value greater than a number, I know it says greater than or equal to, just change the inequalities. Then we're going to set up 2 inequalities. Inside greater than or equal to the number. So inside greater than or equal to the number, or inside less than or equal to the negative of the number. Again, the visual is, this is saying that this fraction is either more than 4 spaces to the right, so to the right of 4, greater than 4, or more than 4 spaces to the left, so less than or equal to negative 4. And now we just solve both. The fraction shouldn't intimidate you. It's a division problem. The answer of dividing is multiplying. Multiply everything by 3. We're going to solve all these at once. 3 for you, 3 for you. Everybody gets a 3. Cancel. X minus 1 is greater than or equal to 4 times 3 is 12. Or cancel. X minus 1 less than or equal to negative 4 times 3 is negative 12. Add 1 to both sides, and add 1 to both sides. We get x is greater than or equal to 13, or x is less than or equal to negative 11. So if we were to draw a number line, greater than or equal to 13 means to the right of 13 with a bracket. Less than or equal to negative 11 means to the left of negative 11, also with a bracket. For the union, since they're 2 disjoint intervals, we have to write an interval for each one. So negative infinity comma negative 11 with a bracket, union, bracket 13 comma infinity. I do want to remind you that there are technically some union problems where the intervals actually join together and make a single interval, but in this case they don't. I didn't add too much time to the video.